Hello and good morning or good afternoon, everybody, depending on where you are. So, as Will mentioned, this is a presentation about how we marry some technology that we have at ETAS to do with our middleware solution, primarily supporting the AutoSAR Adaptive platform, and looking at how we join that and connect that to more enterprise class data management. So typically in automotive, we are doing things like writing APIs, managing bits of data on a low level. But actually, as we move to a more software-defined vehicle approach to building and integrating and maintaining and modifying car software over the long haul, actually, that's the kind of problem that other industries have done for many, many years, and they've used databases for doing that. So what we're looking at today is how we basically get data out of the sort of embedded end of an ECU, put it into a database, and then that allows us to do in terms of manipulating and modifying that data, and then being able to essentially extend and create new views on that. And for those of you who are SQL aficionados, you'll recognize that the title of this presentation is actually an SQL query. So select useful things from your car where the data source is equal to AutoSAR Adaptive. So just a quick introduction to ourselves. As Will mentioned, my name's Dan Buttle. I'm head of product for RTA Solutions at ETAS. I've been at ETAS for quite a long time now, so nearly 20 years. I've got a background that covers sort of telecoms, avionics, but primarily automotive. And I'm a deeply embedded guy. So I'm really down in the bits and bytes, flipping things in registers, doing operating systems, looking at programming language, real detailed interactions down at the deeply embedded level. Carl comes from a completely different end of the software engineering spectrum. So, Carl, do you want to introduce yourself?
And my background is, well, mathematics, but the point is I ended up doing all sort of big projects where we talk about software engineering on a large scale, and everything in my world always revolved around databases being the logical and the only feasible store for information when you build real and reliable and big systems, and small.
And small ones too.
Right.
Good. So, okay, thanks. So what are we here for? So we're going to look at essentially three kind of things here. So we're looking at how we enable access to data in automotive systems, actually without needing to know about the underlying embedded software, the middleware, or any APIs. So there's a whole bunch of stuff that might be happening on the deeply embedded level. But what we're going to do is we're going to pull out the data that we're interested in, and put it in a place where people, without necessarily having automotive background, experience, competence, or knowledge, can still manipulate and use that data. So that actually opens up the use of the vehicle data to a massively broader set of people than maybe a sort of traditional automotive approach. So anybody who can write an SQL request from any programming language can ultimately get access to the data. And we'll have a little example later on looking at exactly how we do that. What that enables us to do is to allow us to add new use cases to that data that emerge after the vehicle's gone into production. So we might be gathering a load of data around the vehicle, putting it into one place, but we can start beginning to sort of play the what-if game or make queries on that data in much the same way that you'd use a database in a non-embedded application. So that allows us to do things like spot data trends. So we might want to start looking at, okay, how often does scenario X happen when Y happens? So if you're beginning to notice things like, okay, you're getting some kind of fault sequence happening in the car, you can then start using that to trigger, okay, what data am I going to collect when I start seeing a fault curve in more data? And I can do that dynamically without touching any of the underlying software where I'm pulling that data from. And you can also do really cool things like turn discrete data into time series data. So show me how values change over time. And you can do all of that without changing any single line of the embedded software that's gathering that data. And we'll show a little example about how to build exactly that kind of application later. And so with the ETAS and the MIMA solution together, it's a quick start of those technologies. We've got a pre-configured reference integration of the ETAS solution and the MIMA solution using AutoSAR Adaptive as the data source. So we can basically use the persistency model of AutoSAR and dovetail it onto MIMA's solution. So what we're going to do today is we're going to follow 4 steps. So the first step is we're going to do the installation of the VRT starter kit. I'll talk about that in a little while. I'm going to check that works. Then we're going to install MIMA, and then we're going to do the little bit of magic, which is essentially doing a switcheroo to move from a normal AutoSAR implementation of the persistency model, so how AutoSAR stores data in AutoSAR Adaptive, and to actually make that talk to Mima. And then Carl's going to take over.
I will build a small application, an RTA-VAT as an adaptive application that does this. Generates data, stores in the database, and I will show first how that works and how I end up with storing things in the normal way. And then comes the nice part, and the step 4 is where I start to manipulate this data and start using the database as the tool that is to provide the sort of time series that Dan just mentioned. And on Encore, I will also look at a small application just to show how I can then access this data from the outside world. But more of that later.
More of that to come, yeah. So the first thing is we'll cover the installation to just show you how easy it is to get up and running with our Adaptive AutoSAR starter kit. So what we actually have is we've got we supply the AutoSAR adaptive solution, but in order to make it much easier for people to sort of get up and running and make that first step into the AutoSAR adaptive world, we have a thing called the starter kit. So essentially, that's a pre-configured software development kit, and we supply it as essentially a virtual machine image. It sits on Debian Linux. All of our tools are installed and set up, ready to use, plus some other help utilities that we can have a look at. There's a whole suite of examples built into that, and then there's also a bit of infrastructure to allow you to play around with virtual ECUs. So you can see that on the right-hand side here if I find my mouse pointer. So we've used some QEMU virtual machines, so we can support Intel architectures and ARM architectures, and we can support QNX and Linux on those architectures. And there's a simple network that allows us to basically build applications on the host PC and deploy them onto virtual ECUs. So you'll see a little bit of this later, but we can also make that virtual network that we're running. So it's a virtual tap network. It can also talk to external networks. So you can also talk to Graviton systems or using Spotify Amazon Web Services, or you can talk across an Ethernet bridge and out onto real hardware. So you can actually have a virtual ECU talking to a real ECU. So running on an evaluation board, all running the same Adaptive AutoSAR platform software. We support the starter kit on both Oracle VirtualBox and on Amazon Web Services. What we're going to do today is we're going to look at the VirtualBox version of it, just because it's the easiest thing to sort of show you and set up. We'll look at it running primarily on Intel architectures, and we'll look at it primarily using Linux. So the most straightforward way of doing things. Okay, so if we want to look at the install then, here's my VirtualBox. So the first thing I am actually going to do here, again, when I find my mouse pointer, is I'm going to add a new virtual machine. I'm going to try and find it over here, which is over here. So I've just got a VirtualBox image here that contains that setup. I just have to open that. It sets it up inside the VirtualBox. I can just power that machine up. So this will take a little bit of a while for.
This is the VirtualBox that comes from ETAS.
This is the VirtualBox that's coming from ETAS, yes. Right. So, and I just need to find it now as it's booting. So it's booting on my other monitor. Just bear with me a second. So this will take a little while to boot. But basically, for those of you who used to working in Linux, you'll be able to see that. Oh, sorry, wrong thing. Let's see that it's not message again. We're good to go. And let me just shrink it and re-expand it. So here we are. So that's taken us 30 seconds to get going, maybe a minute. So we've basically pulled in the virtual machine. We're now booted it, and this is basically the default setup. So just talk you a few little set of things that are on the desktop. So Isola VRT is our main configuration tool. So that's the thing that you would actually use for configuring and driving the build of the systems. We've got a couple of help utilities that are shipping. So there's a copy of the DLT viewer if you want to look at diagnostic log and trace messages, and there's also Wireshark if you want to have a look at what's happening on Ethernet. All these blue things here are actually the entire user documentation set that's dropped onto the desktop. So this includes things like how you get started, there's tutorials in there, there's a whole set of worked examples, there's use guides, reference guides, everything. So there's a huge amount of information that you can use that just ships as part of the standard product to allow you to get up and running with it. There's a thing called confidence testing. This basically allows us to check that we've commissioned and set up the environment later. I won't run that because that takes 2 or 3 minutes to run. But basically, just double clicking on that, it will just work out whether we can create, configure, build, and run things on the virtual network. Okay. So what I'll first do is I'll open the VRT tooling. So this is an Eclipse-based application. It'll take a little while to start to fire up Eclipse and Java in the background. And this is what we actually use as our sort of main development environment. So it'll ask us for a workspace. It'll probably then ask us tell us about safety advice and using it in serious production environments and all those kind of things. So here we go. Just booted that. So yes, there's some safety advice, and yes, we've all read that. So this is our sort of main work environment. So what we can do here is we can basically import a set of examples to this. So we can go normal Eclipse workflow here, import general existing projects into the workspace. And essentially what gets installed on the, we create a developer account on here, and there's a file under here, VRT and projects, and what this actually contains is a whole suite of projects to allow you to explore parts of the AutoSAR adaptive solution. So we've got a whole set of things to do with communication management here in sort of, various little simple examples so you can understand what's going on and how things get configured. There's things to do with crypto and diag. There's some execution managers that manage things. One of the interesting ones is the OneArg here. That's the simplest thing you can build with it as an adaptive application. There's some state management things in here. There's some persistency things which we'll have a look at briefly. Signal to service, update and configuration. So there's a real good suite of example applications here. So if we just open that, so it'll just say and click finish. So what? Oh, sorry, I need to do that again. File, open. Sorry, I selected all. I should have selected all the projects. Let's go back. Let's do that. Let's open at that level. So let me go back again. I want to go back up here. So not folder. Right, so let's finish that. So let's pull them all in. There we go. Yeah. So that's pulled all those projects in here. So we initially looked at the OneArg. So each of these projects is entirely self-contained. There's all the AutoSAR XML configuration information for that. And then there's the source code. So just to give you an idea of how simple you can start with, if I open this C++ program here, this is the most simplest application that we can actually build. So let's just have a quick look at that. So you can see here, let me just switch on the line numbers, top of the line numbers on, that we've got essentially 80 lines of code, of which about 40 lines of those are comments. So we've got 40 lines of application here. So this is a really simple main application, simple argument passing. It basically creates a logger, sets up that logger, and then just basically drops out argument count into the log stream, and then just essentially shuts it. So it just sits in that loop, putting those arguments in and then dropping it into log and then exits. This is about as simple as it gets. We've also got, and this is more relevant to what we're talking about today, persistent data storage. So we've got a whole set of things to do with persistent data storage, but actually if we look at some code here, we've got a slightly more elaborate model where if I move to the bottom of this, we've got a more interesting main program that's actually doing some data storage and collection, so for storing persistent data. So it's basically looking at how we read and write from files. It's looking at how we store key value pairs in data. And all this code ships as part of the starter kit. So what we can actually do is have a look at how we would build that. So if I open a terminal window and go to CVE projects, We ship a set of utilities called RV, so for RTA VRTE. So we've got a command called RV build. So this allows us to build build an AutoSAR adaptive application to run on a virtual machine. Okay, I'm going to put a -D flag onto that. Hang on a minute. I'm going to set the keyboard first. Sorry, I'm just working on a keyboard. Let's turn my keyboard into German because that'll make it a lot easier. And RV build. So RV build -D. -D, what it will do is it will not only build the virtual machine, but it will deploy it. So if I look at things like building the Arapur example, and then I'm going to deploy it to one of these virtual machines. So they're all set up on a tap network, and basically the last part of the IP address becomes a machine ID. So all the machines from 10, 11, 12, they're all QNX machines running on Linux. 20, 21, 22, 23 are all Intel machines running Linux. And then the 30 machines are our machines on QNX, and the 40 machines are Intel machines. Our machines running Linux. So I'm going to put a magic number in here, but it's not actually a magic number. It's the identifier for the virtual machine that we want to run it on. So I'm going to hit build, and if all goes well, this is actually going to it's going to take all of our AutoSAR XML configurations. It's going to do all the code generation with that configuration to create all the essentially the manifests and the wrappers to allow us to talk to our implementation of adaptive AutoSAR. It's going to build and link the application with that code and create that redeployable application as a dynamically locatable file. And then what it's going to do when it's should its way through here is it will actually fire up the virtual machine to then run it, and then you'll see a window pop up that is basically a terminal window that's showing that virtual machine running and logging. So looks like it's just about got through to finishing the compilation. So you can see now it's done the build. It's basically set up it's copied that data into a deployment location. So we've basically set up an NFS file mount on the host side, and then we're going to boot this machine for the first time. So typically, I will apologize at this point that I'm running on a very low-powered laptop sat in a meeting room. This would typically take 4 to 5 seconds running on a more beefier developer machine. This is running on a dual core Intel device. So yeah, it takes about 30 seconds here. And it will then. It's about to change the IP address, and then it's going to boot the virtual machine. So it's just about to start doing that now. So just bear with it a little bit. It's obviously the morning here in Germany, so maybe it's not quite as awake as it might be in the afternoons sometimes. I'll just have a drink while we're waiting for that. Good. There we go. Okay, so now it's spun up it's just spun up a terminal window, and it's just dropping out a whole bunch of logging information in terms of what it's doing. So you can see as that is scrolling past, it's reading and writing data to blocks. It's looking at file systems. It's creating with those redundant data storage. It's writing those key value pairs, and it's logging all of that to that terminal console. So there's quite a lot of interesting things that have gone on here, but this means that we've done a really simple check. We've installed the starter kit. We've built an application directly from that starter kit, and we've spun up a virtual machine and run the application running our adaptive AutoSAR platform with this application sat on top of it. And that's taken us maybe 5 minutes from having zero to having the thing up and running. And this is the point at which you would normally kick off and start to explore what we provide and what we allow you to do. Okay, so if just need to minimize that and go back here. So the next step is to add MIMA enablement. So what we're actually doing here is we need to do some if you think about how adaptive AutoSAR normally works, we've got the persistence that allows us to do data retention, data consistency, data access, and data management. So you've essentially got this API over here that applications talk to, and that basically acts as a broker for doing either storing files on the system, and you can also create redundant copies. So you've got some kind of backup there with sort of checksums to check for data corruption, and we can also do sort of key value storage. What we're actually going to do is going to replace the bottom right part of that picture. So if we take this example, what we're going to do is we're going to take a MIMA-enabled version of the AutoSAR persistency layer, and we're going to basically replace our library with that. But we're going to ensure that the top part of that library to the applications maintains exactly the same interface. That then allows us to replace all of that infrastructure with MIMA's SQL database. And when we've done that, what that means is we can then access and manipulate and create those new data views. Okay, so if I now move back to my VirtualBox, basically what I can do here is, on the pointer again, and I quickly look at, so open this in a terminal. Normally, there's a little proxy application that allows us to do all of this, but essentially we provide there's a couple of deb packages and a zip file. So the deb packages are for the Linux versions of MIMA, and the zip file is for the QNX version of MIMA. Normally, what you do is there's a little helper application which will basically go to the MIMA website, fetch this, and install it really simply. Because you probably don't want to watch us looking at a download happening, what we've done is we've downloaded that already, and we've just written a simple script called install MIMA. What that does is it will basically install those deb packages and that zip file for us. So if you run that, it will ask us for a password, which we tell you when you buy the starter kit from us. But that will basically go away and install MIMA for us. Okay, so that's now done. It's a relatively quick thing to do. And what we also now need to do is we've got an RV install application, RV install MIMA. What this does is this is the thing that does that initial switch between a normal native AutoSAR persistency layer and a MIMA-enabled version of that persistency layer. So if we do this, it will basically set all that up. And if I now go to my projects again, let's see how VRT projects. Then there's a KVS, an implementation of the KVS and the MIMA example there. So, and I can basically go into MIMA KVS, and there's essentially a build script and a deploy script here. So just to show that you can actually build it. This will do a build. We're going to build for Linux, and we're going to build for our AMD 64. So, and this is basically going to take the binding that binds our persistency library onto MIMA. It's going to build that. So we provide all the source code to show you how that actually works. It takes a little while, and then we can actually just deploy that onto into the deploy. And we can just do a quick deployment of that, which will delete some various bits and pieces and copy that into the virtual machine images that we're setting up. Okay, so we've now got to the stage where if I look in opt, I've now got not only opt ETAS with all the ETAS things in there, but I've got an opt MIMA SQL, which actually contains, if I look in MIMA, we've got essentially QNX and the Linux versions. I can look at Linux, AMD, and we've got essentially all those x86, isn't it? So we've got basically all the binaries, the examples from MIMA, all the header files and all that kind of thing. So we've now got the starter kit installed, MIMA installed, and now we're ready to actually look at the next stage. If I go here and minimize this again. So we're now at the ability to boot. You can start to run a RTA VRT application. So I will talk through the application, then we'll switch over to Carl, who's going to talk us through what we actually do here. So to make this simple, we've got two sensors. So we've got essentially a sensor doing temperature, which is represented by the little engine here, and a sensor doing speed. What we're going to do is we're going to write a really simple C++ program that essentially simulates discrete temperature and speed data, and it's going to store that data using the our persistency layer API. So that's C++ API into the adaptive platform for storing those values. So that basically pushes it into VRTE, and then behind the scenes, VRTE will push that into MIMA. Okay, so Carl, do you want to show us how that's done and just give us a little view of that application?
Does that count? So, right, here we are with the starter kits. And as Darren mentioned, there are some sample codes in this system. One is the Mima example. You can probably see that at the bottom of the screen. And I've built my project on top of that. So using that as a template. This is very, very simple one. I have set up my source code so that it will just do these things. I'm playing around. I got my speeds. I got my temperature. They're my simulated sensors. So the whole idea is that I will just run through this. I will generate 15 samples and I will store this using the array per call. So this is exactly the same way that any array application would do it. But in this case, it will use the Mima database in the background. So
I mean, if you'd written this code already and it was working on a normal AutoSAR adaptive application, you don't have to touch the code.
Exactly.
We're going to make it completely transparent for you.
And in exactly the same way that we did the build for standard application, we do the same thing with the Mima build. And I will now deploy this on my machine 20, the same way that Darren did. So let's start the build project. And it's exactly the same as Darren did it. It compiles everything. And it will then eventually create a small virtual machine that starts. I have the same caveat as Darren. I'm running this on a laptop, so there will be some delays. There will be delays now, and there will be delays later.
Yes, so if any of you are listening have ever watched the film Inception, it's a little bit like this. So we have virtual machines inside a virtual machine, in another machine. So it's basically like an onion. So we've got lots of layers of virtualization running here, which just goes to show that modern technology is actually quite wonderful. That you can do this in a practical and time efficient way.
And just for good measure, the point I'm running this on a Mac. Darren's running this on a PC.
Yeah, I'm running it on a PC. Yeah, I'm a PC and you're a Mac.
So here we go. Now this starts, you can see, and the first thing that happens, this is the first time this machine boots. And since it's the first time, this would be typically in the pre-production before you deploy these things, it will create the database. Now this is a first, of course. The database will be reused whenever you start the system. But now you see the creation parts, and that takes a little while. And once that is done, it will then start the database and start to populate it using my codes. And so they're part of the sample code. If you run the Mima example, you see a lot of examples of how to store, retrieve data, and how to exercise that connection. So now the database is launched.
Yes, we've got our DB, so our adaptive AutoSAR database. Yeah.
And I will now use a free tool called DB Visualizer. You can find it at dbvis with an s.com. And I use this to talk to my database. So this is it. I'm running this inside the VirtualBox. I'm now connecting to my virtual machine. So the one we have, here we are. So this is the virtual machine that's running. It's doing all the stuff that we set up. So it's pre-populating things. It's running part of the test. I removed most of the things from the Mima example. But in this case, I've left few things for the test cases, and then I will run my things, and they will come in a sec. Where it says the webinar test. And let's see, and here we go, webinar code, and now it was fiddling. And so let's go here. We'll see, this is the database view. And as you said, so I set up things, and I have my schemas. This is my database. These are my tables, and this is the interesting part. This is where we store all the key value pairs. So I'll open that, and if you look at, well, that opens, I'll do it that way. So here we go. I did my 15 runs, I said, and the point is, this is a key value store. So I've written all these things, but the point is it replaces them. That's what key value is. I say temperature is this, temperature is this, temperature is this. So whatever is stored is the latest. And if we now look here in the database, you'll see I've got my 23 and 85, and that is exactly what I've got here, my 23 and my 85. So that was how to build a small Vimo-enabled application and run it.
Yeah, and so far, if you're using the adaptive AutoZAR persistence layer, you're thinking, well, so what? You've just taken the value and moved it from key value storage that's maintained by AutoZAR itself, and now you just put it in an SQL database. Mm-hmm. But this is actually where the value of this comes, because obviously we've got last is best semantics that Carl mentioned. The latest value is the one that's stored. But we've sort of lost all the history of those older values. And if we wanted to persist some history, now we'd actually have to go back, modify all that source code, change the application, build some buffers, and actually build some sort of history tables and this kind of thing. But what you can actually do now, it's in the database, is not do any of that. You don't have to touch any of the provision of the data code, and that's going to be the next thing that we're going to look at. So if I share my desktop again, mm-hmm. So what we're now going to look at is, now we've got that data in a database, what can we do? How can we manipulate those data elements as a first-class value in the system? So essentially, this is where we started. We've just got some data and we just pushed it into the database. But we can do all kinds of things now by looking at that database from the opposite side. So for a start, we can look at putting in queries there to sort of view that data and see what values are stored. So that's essentially a reading operation out of that database. But much more interesting is we can start building things on the back of that data. So we're going to look at how we build new views. So we're going to use SQL triggers, and they're going to create time series data values. So basically, we're going to be able to pull and read and write to that database by creating new views of existing data. And then last but not least, just for a bit of fun, we're going to show you how you can actually just use the programmatic API to access that database from an entirely separate application in an entirely separate programming language. So in this case, we're going to write a little Java application, and that's just going to pull the data out that we've got, looking at the data that's in our new views, and show us something interesting based on that. So this is where we are at the moment. We've got that key value store, which is what we would typically have in adaptive, and we've got a speed and a temperature, and we've got the last two values that we wrote into that, and there's a test value in there as well. But what we're actually going to do now is to elaborate on this and create new data based on the old data.
So we started with this. This was a table, the key value store, called keyval tab. And what I will do is add two new tables that we didn't have before, a table for my speed history and the table for the temperature history. And I will call them then hist tab and temperature temp hist tab. And my point is, things I'm interested in is those two values, the speed and the temperature. And how to create a history of this is, okay, so I need to find a way to react on changes in the database. And whenever I see something, then I can do something else. Now, this is called a trigger. So I will add a trigger, not only add these two tables, but I'll add this trigger. What the trigger does is whenever the trigger is connected, tied to one table, in my case, I will tie it to the key value tab, and we'll look at whatever's going on there. So there could be any sort of key value pairs, but it will look for specifically the speed and the temperature. And if it finds that one of those, it will insert into the corresponding history table.
And it's just going to look for changes in that data.
Exactly.
I mean, I guess it could look for anything. It could look for exceeding a threshold or going below a threshold or something.
Exactly. So the trigger is something. It triggers on something that happens. It could be, in this case, it's an insert trigger. It could be delete or update, whatever, when you change things, and then you can start to do other things. So it's a way of hooking into to your flow and having other things, sort of programs running that does that on data changes. So if you step one forward, that would be, this is the trigger. It just takes those and insert them. And so let me just show that. So I'll just go back to my virtual machine, the one that had run previously. So we're back here again. So let's start. I will now add my triggers, and I do that this way. I have a set of SQL statements here. as I said, I would create a speed history table, for instance. That's my first thing. But this table I need, as a good practice, you need a primary key in a good database design. And there is no such thing in the data insert that would serve as a good primary key. So we have something called a sequence. That is an ever increasing number that gives a unique ID for every row in the database. So I'll start by creating the sequence. And once I've done that, I can then create my table for this purpose, for the speed history. And I will then do the same thing for my temperature history. I'll create a sequence for that guy, and I will create my table for that. And now comes the interesting part. This is my trigger. So as you can see, I will do something after insert on my keyval tab. And okay, so this is when I enter this code, and I will then look for speed. If I find speed, I will insert the value into the speed history tab. And if I find my temperature, I will insert that into the temperature history tab. So let's create that trigger. That's done. And now the trigger is in here. You can see the trigger, I've got my sequences, and I even got my new tables here up and running. Let's then briefly go back here and look at my virtual machine I was running. I will not kill this one, stop it, and then I will relaunch it again. So this is closing everything, and then it will remove that. So now it's killed that process, and I will, in the same way, do an RB run, start my machine again.
Yeah, so we're going to start exactly the same machine that we started last time, and we've not touched it. Yeah.
Exactly. And this time, so now you see it doesn't create the database, it just launched everything, starts database, and starts execution. And so let me then reconnect here, because I lost my connection. As I said, remember, I killed my machine, and I had to connect that one again. And we go back and see how this is running. We got this starting. And let's see where we are. Yeah, the startup. So we're just about to enter the demo code, the example code. And, well, be a bit patient dependent today. They are. Here we go. That's starting.
Good.
Yeah, exactly. Adding the keys. And these are the test keys. This is part of the example. And cleaning up. And in a short while, we'll enter the demo code.
Mm-hmm.
Here we go.
Yeah, so we're going to write those 15 or so values for the speed and temperature in there.
Now we did that. So that was the 15 values. So, and let's now refresh this table, the keyval tab. The point is, the keyval tab will contain, the flag should contain the last one that was 85 and 23.
Mm-hmm.
So that would be in that table. Let's see if we got that. Hang on. Here we go. But this is the interesting part. We'll now look at my speed history table. And what does that contain? Well, here we have all my samples, so my ID column, and I have the corresponding speed and the timestamps, and the same thing for my temperature history, exactly the same idea that I was proposing. So we've gone from having just only the last value to having every value given a set of rules.
Yeah, and we basically just, and in this case, it's fairly simple. We just said each time it changes, log the change with a timestamp against it, and obviously it's changed on those 15 times. We can imagine a situation where what you might be looking for is some transient problem or transient event in the system, and you say, okay, right, when I see that temperature exceed a value, or when I see that pressure drop below a particular value, you know, let's say it's when I see the tire pressure drop on all four wheels at the same time within a certain threshold, generate me a trigger to say that I've got a vehicle dynamics problem, or maybe back off on or modify something in the stability control. So you've got that way of being able to take individual discrete pieces of data, aggregate it together, pull some useful information out of it, and doing this all by just looking at data as first-class values in your development environment, essentially, rather than having to, I need to write an API to do this, and I need to expose that API, and then I need to subscribe to that API and get the data out of it. Actually, we're just putting the data in a place where anybody can access it and manipulate.
And the nice thing is that you can access the data using any sort of means. That's the point. It's SQL. So, as an example, let me show you something here. I have this small program that I've written, and let's have a look at that. It's just a small Java program. I will connect to my database. I will, read through the database. I will perform some sort of aggregation, very, very crude. It will give me an average, and it will give me the number of samples and so forth. So let's try this. And it's here we go.
And you're going to run this on the host side and connect to that virtual machine. Exactly. So you could actually be doing this from your enterprise system. You could have a vehicle in Wintertest and say, oh, I want to pull out that piece of information from a vehicle in Wintertest. Let me just connect to the vehicle remotely.
If you have the proper authorization,
absolutely,
the database hides everything. You can put up different groups and say, okay, these tables and these data points are only accessible to those who are logged in with the proper credentials. So in this case, I am logging in as the same user as the one that wrote that, but I can build much more integrated works. And here you see I've got my min and max for the temperatures, and I've got my average for the temperatures and number of samples. So there you are. That was my short example for Java. You could just as well do this in Rust or
Python or Perl or whatever your weapon of choice is for development.
Exactly.
As long as you can have some way of making a socket connection, authenticating on that socket connection, and then pulling the data out. Essentially, you can do a huge amount of manipulation. And one of the nice things is that obviously with a lot of new players coming into the automotive industry, or maybe coming from different vertical industries where management and manipulation of data is a standard thing. Actually, we can now make cars and make it truly a software-defined vehicle, because we're treating a car as if it's Amazon's warehouse, for example. We're just doing the same thing. Okay, that's really cool. So I'm going to quickly share my desktop when I find mine. So let me go back to sharing. So, I mean, we touched a little bit on sort of security and authentication. And obviously, it's a database connection. That's a solved problem for the last 40 years in terms of securing and authenticating a database connection. But, I mean, one of the other things we can potentially do is actually look at how we put individual parts of that data and have it in different, more or less secured spaces. So, I mean, one of the things we can do is work. I know in Mima you've got a Mima Trust application. Do you want to talk a little bit more about that?
Yes. Now, that's an interesting add-on. The point is we can store data in the ARM process, something called the trust zone. The trust zone is a hidden away part. It's an execution mode where you can run cryptographically signed pieces of software. So we've done with Mima, we teamed up with a British company called Trustonic, and they provide an operating system sort that runs inside this trust zone. And what they provide is a secure storage that we use for Mima. So they have a storage part, and we have an API on top of that. That means that we can selectively say, okay, this table, now this is a nice part with the relational database, is from a query. It doesn't really care where you store it, where the database stores it. It's just select from your car and where is that data. Now we can say, okay, this table is rightfully.
It's really key OEM data or really key tier one data, and you don't want anybody accessing it.
It's privacy crucial. What have you? And then you can say, okay, we store this inside the trust zone instead. So it's actually we're storing inside a safe. So the application can read it. But the point is, when you close down, its data at rest is very, very safe. And this is the good part. So everything is cryptographically signed, hidden away, tucked away. But we don't do that everything, just to select this, like this and this table on secure. The rest goes to the file system and using the normal securities we have it in Mima there. So it's added there.
And then it's transparent to people actually accessing the data.
Exactly. The database design, so it's an implementation design issue. Not the database provides it. You as the implementer says, okay, I want this to happen here, and then it just works.
Cool. Right. So I think it's now time for a recap. So we originally said at the start of the hour that we would do 4 main things. We would do the installation, check that it works. Yeah, we installed it. It took about 30, 45 seconds to actually fire up the virtual machine. It took us about 5 minutes to look through the examples, build some code, and run a VM using our adaptive platform. We then basically replaced our persistency implementation in our adaptive platform with Mima and updated our code to use that. Then we did some building of an DRT application, and we basically have the same code as what we would be running on the normal per, running on top of the Mima-based version. And then last but not least, actually the really interesting part is we've now got the data in a place where we can manipulate it, aggregate it, view it, trigger on it in the same way that we'd look at any other kind of essentially data mining activity in any other kind of industry, whether it's banking or finance or logistics or something like that. But now we're doing it with data that we've essentially pulled out of the car, turned it into something useful for potential application developers, people looking at new innovations they can deliver on the tops of those platforms, and we're doing it in a data-centric way, not an API and digging into the details way.
Yeah. Also got the means to do a very generalized and ad hoc way of. So you could take a production vehicle and you could use that, and you can analyze what that is going on in that vehicle. You could do things. You could add these things to that vehicle if you want to track some really weird stuff.
Yeah.
So it's not limited to test.
So these emergent use cases. I mean, if you're talking about it's going to be on the road for 25 years, and we want to extend and augment the functionality, it gives us actually quite a good way of pulling this data out. Yeah. Great. Okay, so with that, I would like to say thanks to everybody for your attention. Our contact details are at the bottom, and there's some more information on the ETAS website.
Goodbye.
Thank you. Bye-bye.